Hello everyone. Today we are going to discuss solution of biweekly contest of Leetcode 97. So let's begin with the problem. So first problem, separate the digits in an array. So in this problem here we are given with an integer array and we have to separate digits of each of the integer and then append it to the array. For example, the given array is 13, 25, 83, 77. So the digit split will be 1 and 3, 2 and 5, 8 and 3, 7 and 7, and respectively is written in the given array. So how we will do this? We can do this as we can see that the nums dot length is very less, so we can do it in a fashion that we will convert each of the integer in a string and then get characters one by one and append it to our answer and then return that answer. So here is my Java solution. First of all, I have created a list of answer and then for each of the number I have converted that number into a string and then iterate through each of that character and added that character to the answer here, and then at last I have converted that list into integer array here and then return that array. So this is the solution for the first problem. Let's jump into the second problem. Second problem is maximum number of integer to choose from the range I. So in this problem what we are given that we are given an integer array band and two integer n and maxsum. So and we are choosing some of the integer which follow the given set of rules. The rules are that chosen integer should be in the range of 1 and n, and each integer can be chosen at most once, and that integer should not be in the given array, and the sum of all our chosen integers should not exceed the maximum. So we have to return the maximum number of integer we can choose. So how we can do this? So first of all, we can think of it that like all integers are given and we have to select the integer such that the sum of all the integer should not exceed maximum, and we have to collect the maximum number of integer. So we can think of this in a greedy manner, like we could sort the array and then choose all the minimum integers. So if we choose all the minimum integer, we will have maximum number of integer with minimum sum. Okay, and then we will check if that sum does not exceed the given sum. If the sum exceeds the given sum, we will return the number of integers that we have chosen till now. So for the solution, like first of all, I have included all the arrays, all the integers that are present in the array in a set, so that the retrieval operation in set is O of 1, and added all the elements to the set and initialize the sum as 0, and answer means number of element that we are taking is 0. So first of all, we will check if the current element hour is from 1 to n is in set or not, means if it is present in array or not, and then if it is not present, then we will check if now including that number into sum will result into that our sum should not exceed maximum sum. So we'll check that condition. If it does not exceed maximum sum and also it is not present in the array, we will add it to our answer, like sum plus plus the given integer and answer plus plus, and we will return the answer. This is for the second question. Now let's jump into the third question. Maximum win from two segments. So here we are given with some prices which have position marked on the x-axis, and the given position are in increasing order or like sorted non-decreasing order. So we and also given as there are different prices at the same position. It is also possible, and we are given with the integer k. So what we have to do, like we are allowed to select two segments with integer endpoints, and the length of each segment must be k, and we have to collect all the prices whose position falls within at least one of the two selected segments, including the endpoint. So what basically the question is saying, like we could select a range which have the size of k, and this range we have to select two ranges, and this range can intersect also, and we have to collect all the prices that lies within that range, and we have to collect maximum number of prices. So how could we do that? So first of all, we could think of it like we will create a DP, and then so the all position are sorted in non-decreasing order. So first of all, we will create a range, like for suppose if we encounter 5, so we'll mark 5 as a starting point, and then 5 plus k, that is 2, means 5 plus 2 7. We will do a binary search on this array and find out the position of 7 or the element that is less than 7, and we will include all those elements in our answer, like for in our DP. So for 5, we will consider an answer, and here it will be 1. For 3 plus 2, that is 5. For this 3, it will be 2. For this 3, it will be 3. For this 2, it will be 2 plus 2 4. So we will include 2 3 3, so it will be 3. For this 2, it will be 4. For this one, it will be 1 plus 2 equal to 3. So for this one, it will be answer like 1 till this 3 5 answer. For this one, it will be 6. And now we have to choose two ranges. So what we could do is, like, now we will create another DP, and for we will use this one, and for now we will iterate through that integer array once again, and we will use this one, and for again do a binary search to find till where we can take this range. So from 1, the range will be till 3. So we will consider this as one range, and then we will take another range from the element that is just 1 plus to the last element, so it will be from 5. So we will consider another range from all the elements that are 5 and that, or the element that lies ahead of 5 and 5, and we will consider maximum number of integers that we can choose from the given range, and then we will include that in our answer. So let's try to understand this in code. First of all, I initialize the answer as 0 and my first DP. So in this DP, I have done what? For every integer, I have calculated the endpoint using the binary search, and then included all the elements that could be a part of range in that DP, and set the value of that DP as all the elements that are present in that range. So for another DP, like we are doing, so we will store this DP value as the maximum we can get from this index till the last. So what I am saying is, if we encounter like DP, the last would be only last of this DP, and then we will check from array.length -2 till 0, and we will store at this position the maximum element from this onwards we can get, and we will store this in the DP, and then we will run a loop once again, and we will check for the endpoint of that element, and then we will mark it as max1, and the max2 will be what is the next possible maximum number of elements we can get, and we will include that in our answer and check if the answer is maximum or of our current number of elements is maximum, and then return the answer. So this problem is very similar to the problem as of stock span with 2 transactions allowed. You could see that for the reference also. Now let's jump into the last question. So in this last question we are given a n by n binary matrix. So what we have to do is, like, we can flip any one of the bit in this matrix, and we have to check whether if the path is possible from the starting index to the ending index, like 0, 0 to n minus 1, m minus 1 comma n minus 1. If there is a path possible even after flipping the index, then we could return true. But if there exists such a if there exists such a square that if we flip the value of that square and then there doesn't exist any path to reach the last element, then we will return true. And if there the path exists, then we will return false. So how could we think of it as, like, we have to find the articulation point. So how we could think of like if each path is passing through certain point, so we just have to flip that bit so that there doesn't exist any path to the last element. So we have to find that bit. So how we could find that, like, if there are, for example, if there are these two paths are disconnected, means disjoint path, so even if you flip any bit, there would always be a path that leads to our last element. So but if there is a single path that is common in all our paths, if there is a single point that is common in all our path, then we could flip that bit. So we would take a single path and flip all. The intuition behind this is we could take a single path and flip all the bits in the given path. So if our required point is in that path and it is flipped, so there will not exist any path from our starting point to the last point. So if it does not exist, we will return true, but if there exists, we will return false. So let's say how I have implemented it. First of all, we will run a DFS from 0, 0. In this DFS, what I have done is I have marked all the points that I am visiting as 0, and also calculating how many number of paths are there. So, and at last and then after this I am again marking 0, 0 point as 1 because it is marked as 0 in the first iteration. So in the second iteration, once again I am calculating number of paths present from 0, 0 to last index. If the number of paths are greater than 0, then we will return false, but if it equal to 0, we will return true. So that's it for the solution for the last problem of biweekly contest 97. Hope you like it. Thank you.